Viewers, welcome back to my channel. In this session I shall discuss another example on cyclic redundancy check, which is an error detection method. So in detail I have given the explanation in my previous session. If you are unable to follow the procedure with one example, or if you are unable to get the concept with one example, let me take another example here, example 2. So in the example 2, whatever is the problem statement, in that the data value will be given. The data given, let us assume as 100100, fine, and the generator value will also be given in the problem statement, and it is in this case 1101. So these are the given values. This data along with some bits get appended to the data and it is sent to the receiver. So now let me show you here the scenario. This is the sender and this is the receiver. Normally what is happening, the sender, whenever it is sending the data over during the transmission, there is a possibility that the bits in the data may get corrupted. Whether single bit gets corrupted, more than one bit gets corrupted, or if there is a burst error, all these three types of errors can be detected using the cyclic redundancy check. First, let us see what does the sender do. At the sender site, I will write here at the sender site what is happening so that it will be clear to you all. At the sender side, the data value, which is 100100, okay, if this is the data value, the sender is appending now 30. Why these 3 zeros are getting appended, and this becomes now the new data, fine, which the sender will be sending along with the generator value. Generator value is 1101. Now why these 3 bits are getting appended? Just count the number of bits in the generator. Number of bits in the generator is how many? 4 bits. So we call this as n with lowercase n equal to 4. Now n minus 1 becomes what? 3. So these many bits has to get appended. Number of bits to be appended is always n minus 1. Came to know this is the procedure in order to add the number of zeros to the data, and that becomes the new data. This is the first step that is happening at the sender side. Now the sender will take this new data, fine. So let me write here in small font size so that I'll be able to cover all these steps in one screen. 100, 100, and these 3 appended bits. So now the sender is trying to divide this data with the generator. The generator given is 1101. So carry out the division here, the binary division. So let us perform the XOR operation. Okay. This bit will get discarded. You will bring down this 0. 1101. Then perform the XOR operation. This bit will not be considered. Now next, bring down this 0. 1101 into 1 is 1101. Perform the XOR operation. 1110. This will not be considered. Bring down the next 0. Once again, it is 1101. Perform the XOR operation. Now here you have 2 bits. Okay, if you bring down 10, but the number of bits here is 3, which is lesser than the divisor. Divisor has got 4 bits. So what we have to do is we'll bring down one more 0. For that reason we'll write here 1 and then bring down the other 0 also. Then 1101 into 1 is 1101. Fine. And what is that you are getting? Now 0 in XOR with 1 is 1. This is 0, this is 0, this is 0. If you compare this with the previous example, there you got 6 bits in the remainder, and out of 6 bits you were considering only the 4 bits, and that was getting appended to the actual data and then sent to the receiver. So let me tell you what were those 6 bits in the remainder also in the previous example. You got 001110 as the remainder. So that means the number of bits are same, only these 4 bits. 4 bits are considered. Okay, 1110. This is because the logic is the polynomial value which was n, when you subtracted n minus 1 in the previous example, n was how much there? 5. Okay, 5 minus 1, 4. So this 4 bits should be equal to what? Whatever you get from the remainder, you have to reduce it to 4 bits only. You have to ignore the leading bits in that remainder and then append it to the data and then send to the receiver. So that's coming back to this example. So in this example, you got remainder is how many? 4 bits. Okay, 4 bits are there in the remainder. Now out of this 4, you will ignore this and consider only 0, 0, 1. This 3 is equivalent to what? This 3 number of bits is equivalent to this one, that is whatever polynomial bits you had, minus 1 equal to 3, and that's why in the remainder also the sender will send only these 3 bits. That means while sending, it will append these 3 bits to the data. Now, so what was the data? The data value is original data, I mean to say 10010. This was the original data. 100100. This was the original data. This original data, these 3 bits will get appended 001, and this will be sent to the receiver from the sender side. So the steps at the sender side is completed. The sender is now sending this data. Now let us see what will be the value for the receiver. Of course, when the data is sent to the receiver, the sender also sends what? The polynomial value 1101. Along with that data, the sender sends 1101, that is the generator value. Now what is that the receiver will do? I'll tell you the steps at the receiver side. The receiver side will get these values from the sender. Once the receiver receives these bits, what the receiver is going to do? It will perform the binary division. Now carry out the binary division 11101. Perform the XOR operation. Discard this, bring down this 0. 1101 into 1 is 1101. Then 1 XOR operation 110. So this 0 will not be considered. Now next, bring down this 0. 1101. Perform the XOR operation. Next, bring down this 0. It will be what? 0. 1101 into 1 is 1101. Perform the XOR operation. These 2 zeros will not be taken. Now you will bring down the next bit. It is 0, but here only 3 bits are there, 110, but you require at least 4 bits here because the divisor value is 1101. So you will bring down the last bit also. So you have brought down 2 bits here, 0 and 1. That's why what you will do is you will put a 0 here, and then 1101 into 1 is 1101. Perform the XOR operation. You are getting all zeros. So if the remainder value is all zeros at the receiver side, then there is no error in the data. So it is clear to you all the complete explanation for the cyclic redundancy check error detection method. If you find this session useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.